your organic chemistry evaluation exam. Class, just a quick reminder, your EE for our chem, similar with your other subjects, we have 80 items. So to achieve at least a 70% ratings, you need a minimum score of 56. Alright, so hopefully tandaan nyo pa yung answers nyo because in this video, we'll go through the answers and their corresponding explanations for each item on your EE. So for org chem, remember, I only handled the first part. So that's the basic organic chemistry from your structure and physical properties until the chemical reactivity and the structural features of your alkenes, dienes, and alkynes. So class, again, i-cover ko lang po yung 40 items or the basic organic chemistry part ng evaluation exam. So with that being said, start na tayo with our first item. So this one is actually related also to Gen Chem. What is the oxidation number of carbon in methanol? Class, remember here, we have a neutral organic compound. So meaning, okay, ang oxidation number ng compound na to in total is equal to 0. So let's see our particular choices. So in order to get the oxidation number of the carbon atom only, dapat alam natin ang rules in your Gen Chem. So remember class, here we will take into account the oxidation numbers of each atom that is participating in the bonding here in our methanol. Okay, so I already tabulated here our atoms. So usually si hydrogen, it will adapt a positive 1 oxidation number. So dahil meron tayong 4 hydrogens, it will contribute to 4, okay, positive 4 in particular, oxidation number. Next, for oxygen, class remember strict follower din siya ng octet rule. So in order to be stable, it should have an oxidation number of -2 and unknown po si X. Okay, so remember these are the atoms that are in our methanol compound. So remember 0 po ang total na charge niyan. So that's why if we isolate X here, our answer should be -2 for the oxidation number, ni carbon. Alright, for number 1, answer is A. Okay, so next item, which of the following compounds can contain exactly 1 triple bond? O sir, gagamit ba kami here ng degree of unsaturation? Yes, a very good class. Again, dapat alam nyo or you are already familiar and memorize nyo na ang DU formula. Okay? So remember class, kapag triple bond, exactly 1 triple bond lang daw. So that's our keyword. DU is equal to 2. So if you're going to compute the degree of unsaturation of our 4 choices, class, the answer here will be letter C, C6H10. And actually, this one follows the general formula for alkynes. Okay? So kung memorize or familiar na kayo with the general formula ng alkynes, this is just a pretty straightforward question. So for number 2, answer is letter C, C6H10 is actually an alkyne. I hope it's clear. So now proceed na tayo with our next item, number 3. How many sigma and pi bonds are in a molecule of C2H2? Sir, parang alkyne din yan. Class, here are the choices. Oh, actually, very good assumption. This is an alkyne. So it follows the general formula for your alkyne. This is our simplest alkyne, si acetylene or, of course, si ethine. Class, ito po ang balancing model ni ethine. Remember, for the CH bonds here, we have sigma bonds. So correspondingly, we have 2 sigma bonds. Sir, yun lang po ba ang sigma bonds? No. Di ba remember sa triple bonds, meron tayong 1 sigma bond and 2 pi bonds. So, in total, ilan po ang sigma bonds? 3. While our triple bonds will be equivalent to 2 pi bonds. So for number 3 class, answer here is letter D, 3 sigma bonds and 2 pi bonds. Alright, so number 4. Which CH bond has the smallest bond dissociation enthalpy? Class, remember, kapag meron ng smallest bond dissociation enthalpy, the product is most stable. So meaning, here class, ang mapo-form kasi natin is your radicals. Okay? When you cleave the CH bond, ang mapo-form is your radical. Class, here in our number 4 question, ang answer here is letter B because it will form, sir, parang ano lang yan, secondary radical. No class, alilik po yan. Okay? Alilik siya because your carbon that will form a radical is directly attached to a carbon that participates in the double bond. So class, remember ha, different po ang stability ng carbocation and the radicals. So for the stability ng radical, the weaker the CH bond that is here, it is to break. Hence, that will just use lower bond energy in order to dissociate our bonding between the carbon and hydrogen. For our radicals, we have, VMP stop. So of course, in terms of the stability, the stable always ang phenylic, next is methyl, followed by primary, secondary, tertiary, and class take note. Always highly stable ang benzylic and allylic. Okay? Benzylic and allylic radicals. So with that being said, if we are going to compare the labeled hydrogens here, vinylic po ang least stable. So ito class, kapag ni-reverse nila yung question, siya naman yung merong highest bond dissociation enthalpy. And remember si allylic again most stable. So of course, it has the lowest B, D, E. So remember class, ang stability trend, this is different with our carbocation trends that we discussed in your crash courses. Alright, so now proceed na tayo with our next item, number 5. Which organic compound has exactly 8 carbon atoms? Class, ang given here are there common names and of course yung IUPAC name nila. So dapat familiar na kayo in converting this one to their corresponding line angle structural formula. Okay? So for our 5th question, remember, here class, ang meron exactly 8 carbon atoms, easy question lang to ha. 2,3-dimethyl hexane. Okay? Ang parent chain hexane meron 6 carbons. Dimethyl meaning meron tayong 2 methyl substituents. Per methyl meron tayong 1 carbon. Alright, class, dapat familiar na kayo with this ha. So number 5 answer is letter C, 2,3-dimethyl hexane. Next. How many isomers are possible for the formula C3H8? Our class, meron na tayong heteroatoms here. Remember, these appeared in the Chemtech board exam last year. Okay? So particularly last year, Chemist and Chemtech board exam. So ang Q-tip ko here class is first calculate the degree of unsaturation para malaman nyo kung meron kayong carbonyl group. Sir, parang nung kinompute namin, wala naman tayong unsaturation. So it's just simply either your alcohol, class, wag yung kakalimutan si ether. We can also form ether with this particular molecular formula. So, class, here are the different isomers that C3H8O can adopt. So it can be a primary alcohol, 1-propanol, our isopropyl alcohol, 2-propanol, and our lone ether isomer we have methoxyethane. So for number 6 class, our answer is letter C. We have 3 possible isomer. Lagyan na po ng asterisk. Again, this is a board exam question both for Chem and Chemtech. Ayan. So number 7. what is the degree of unsaturation of this particular molecular formula. Class, here, gagamit po ulit tayo ng degree of unsaturation. Kaya dapat memorize nyo na to, ha? So, pag binigyan, or if we have a given molecular formula, usually ang gagamitin is degree of unsaturation formula. But kapag given po ang line angle structural formula, straightforward lang class yun, okay? You just really need to count the number of double bonds, triple bonds, and rings in our line angle structural formula. So, going back with item number 7, here is our general formula. So, direct plug-in lang yan. Constancy 2 plus how many carbons? 6 times 2 minus how many hydrogens? 5 plus how many nitrogen? 1. So, direct plug in, our answer here is 5. Alright, so class, again, you can use a different variation ng formula for du. As long as you can get the exact correct type of du, you're good to go. Kasi yung iba nag-worry, sir, parang may nakita po akong variation sa different reference. Class, again, we have different variations, or of course, different references will follow different du formula. So, dapat make sure lang na they have, or they will yield correct du equivalent. Okay, on number 8. Which substance will form hydrogen bonds with water molecules but cannot form hydrogen bonds with its own molecules? Okay? So class, remember kapag hydrogen bonds, we have 3 different atoms capable of hydrogen bonding. That's fun. Okay? Fluorine, oxygen, and nitrogen, they are capable of hydrogen bonding. Of course, first one, hydrofluoric acid. Class, this one, capable po yan ng hydrogen bonding. For letter B, o sir, alcohol yan? Yes, class. Meron pa pong lone pairs. C, of course, oxygen. So capable pa rin siya ng hydrogen bonding with water, similar with your methylamine. Okay? And of course, for ether. Now, sir, are they capable of hydrogen bonding? No, not class. Okay? Because your oxygen somehow, due to the presence of 2 electron donating groups, it's unavailable for hydrogen bonding with its own molecules. But remember, it can still form hydrogen bonding with water. Okay? So remember, class, hindi na siya makakapag-hydrogen bonding with its own molecule. So for number 8, answer is letter D. So with that being said, let's also discuss the general trends for IMFA. Or remember, for the trends, na-discuss nyo na to in your inorganic chemistry. Okay, this one kasi very important though with our discussion on our next item. Class, always take note, if you increase the strength of your IMFA, melting or boiling point will also increase. They are directly proportional in terms of the general trend. Kapag meron kang long dispersion forces, that's typically the weakest IMFA, followed by dipole-dipole, and our strongest type of IMFA is hydrogen bonding. Alright, so class, remember here in our table, summarize natin. If you have, okay, an increase in the difference in the molar mass of your 2 compounds, for instance, you are comparing 2 compounds. So here you have London dispersion forces that will dominate our particular IMFA. So as you increase the molar mass, your LDF or van der Waals forces will also increase. So kapag meron ka ng mga very, very minimal difference in our molar masses, or for instance, meron kang methylamine and methyl alcohol, okay, ang point of difference lang nila is with the dipole-dipole forces. Alright, and now kapag meron kang hydrogen bonding in your molecule, class, automatically always po nagdo-dominate si hydrogen bonding. Okay? For electronegativity, of course, highest hydrogen bonding is found in our oxygen and fluorine. Ang ating weaker, okay, hydrogen bonding is found between nitrogen and hydrogen. Okay, I hope it's clear. With that, let's proceed with our next item. The boiling points of this following carbonyl-containing compounds are 56 degrees, 80 degrees, and 102 degrees Celsius, respectively. This increase is best attributed to an increase in which of the following? Class, from the previous slides, if you are going to analyze the difference between these 3 organic compounds, we are increasing the molar mass because we are adding carbon and hydrogen atoms. Okay? Class, remember, kapag ini-increase po ang molar mass, this will be in our dispersion forces differences. Alright? So class, here is our particular tabulation ng molar masses nila. And as you increase the molar mass, again, I repeat, your London dispersion forces or van der Waals forces will also increase. So number 9, answer is letter B. Alright, number 10. Which compound possesses the highest vapor pressure at 25 degrees Celsius? Class, remember, for vapor pressure, this is inversely related sa boiling point. Kapag mataas ang vapor pressure, highly volatile, so you have lower boiling point. Okay? And remember, ang relationship ng boiling point with IMFA, pag your boiling point is lower, IMFA is also lower. Okay? So with that being said, you will just really need to find out which of this compound has the weakest IMFA. Okay? Letter A, of course. Sir, para may hydrogen bonding capability yan. Very good. Similar with letter C, because we have an amine. Your nitrogen is, okay, capable of hydrogen bonding with itself. And lastly, of course, letter D, of course, is an alcohol. Okay, class, alcohol, remember, this is also capable of hydrogen bonding. Sir, how about letter B? Class, ether po yan. Okay, ethers, they are incapable of hydrogen bonding with its own molecules. It only has London dispersion forces or van der Waals. So, that's our compound that has the weakest IMFA, lowest boiling point, and of course, highest vapor pressure. Class, kapag mataas ang vapor pressure, you are also highly volatile. That's why ethers are always highly volatile molecule. Kaya very swak, okay? Very suitable as solvents for our organic synthesis. We can easily isolate our target product when we use ether solvents. So for number 10, answer is letter B. That's our ether molecule. Number 11, which among this is not associated with aliphatic compounds? Class, hydrocarbons yan ha, your alkanes, alkenes, and alkynes. Letter A, they contain 4n plus 2 pi electrons. Dun palang mali na agad, class, this is Haeckel's rule. And this is characteristic of not aliphatic, but aromatic compounds. Alright? So, number 11, sorry, answer is letter A. Check natin yung ibang choices. Choices B and C, of course, this is the catenation property that allows us to have structural isomerism. Okay? Structural or constitutional isomerism. We have straight chain and branch chain compounds. And letter D, they should have appropriate number ng hydrogen atoms and functional groups. Particularly class carbon is a follower or strict follower ng octet rule. Dapat it has the maximum allowable number of hydrogen atom in its molecule. So for number 11, okay, answer is letter A. They contain 4n plus 2 pi electrons. That's Haeckel's rule characteristic ng aromatic compounds. Okay, on number 12. Which of the following is the strongest Bronsted acid? Or remember the definition of your Bronsted acid? These compounds are, of course, they will easily donate their hydrogen. So meaning class, yung conjugate base niya ay very stabilized. Okay? So here are the choices. This is adenine. This is, of course, our what is this? Amine functional group. This is alcohol, cyclohexanol, and this is our phenol. Okay, class, phenol actually is the answer here because its conjugate base is resonance stabilized. Phenoxide. Remember from your discussions, aromatics and your alcohol, phenol is actually acidic. Okay, so for number 12, answer is letter D. We have phenol. Of course, letter B and C, that's just simply your amine and alcohol respectively. Wala tayong resonance stabilization. So with that, we are done with the first topic. So now proceed tayo with nomenclature. Hopefully, mataas class yung scores niyo with the first topic. So for our next topic, nomenclature, usually chika ng students again. Ang questions here, they will use condensed structural formula like this. Class, wag matatakot. Just remember, always kapag hindi kayo comfortable with these types of structural representation, convert muna. So what is the IUPAC name of this particular compound? So here are the choices. Convert again natin with the line angle structural formula. So here meron tayong alkene functional group. Actually, yun po yung priority functional group natin. Remember our strategy, of course, firstly po is the parent chain, longest hydrocarbon chain that contains our priority functional group. So class, eto po siya. Remember, we should position the alkene at the lowest carbon position. So that's why dapat mag-start tayo ng numbering at the right side. So this is C1, this is C2. So at C2 position, we have an alkene. So ang parent compound natin, we have how many carbons? 1, 2, 3, 4, 5, 2 pentene. Okay? Class, very obvious na po yung answer ha. Let's just double check if we already have or if we really have a methyl substituent at the C4 position. And as you can see here, ayan, we have a methyl at the C4 position. Answer is letter D, 4-methyl 2-pentene. Our next item. What is the name of the compound shown below? Class, here kailangan natin i-take into account ang geometric isomerism, easy isomerism because we have different substituents across the double bond. First thing to do, again, parent chain. 1, 2, 3, 4, 5, 6, 7. Okay, class, again, dapat yun yung longest ha. So here, meron tayong heptene because at the C2 position, of course, we have an alkene. Okay, so with that being said, parent chain to heptene. So meron ba tayong substituent? Yes sir, at the C3 position meron tayong methyl. So answer here should be 3-methyl 2-heptene. So cross out na natin si choice C and D, and now we are left with A and B. Class, again, for the isomerism, cut the double bond, and then for the left carbon that is participating in the double bond, ito po ang priority functional group based on your CIP rule. So, at the right side, ito naman po ang priority functional group. Say they are on the same side. Diba? So, our answer here is letter B, Z, 3-methyl 2-heptene. Class, remember ha, dapat kapag meron kang different substituents, we will follow your alphabetical arrangement. Sir, paano po pag meron tayong prefix na sec, third, should we take into account those prefix in the prefixes? Class, here is the summary in terms of your prefix in the prefixes. Okay? For iso and neo, usually we also take into account this particular prefix. So for iso I, neo M. But for sec and third, they are actually just adjectives. Okay? Secondary and tertiary. So usually they are not counted. So for sec butyl and third butyl class, ang iti-take into account lang natin ay the butyl. So alphabetized under alphabet B. Okay? Letter B lang siya class. So remember, for sec third, usually they are not counted. For iso, neo, as well as cyclo and spiro, we take into account in terms of our alphabetical arrangement. Next. Class, for polycyclics, remember here our mnemonics. Spira, smaller than bigger ring. For bicyclo, bigger than smaller ring. And don't forget, we always start counting at the bridgehead atoms. So what is the name of the spirocyclic compound shown below? Class, again, smaller ring muna tayo. Okay, here is our spiro atom. So let's start counting at the smaller ring. Sa smaller ring, how many carbons excluding the spiro atoms do we have? 4. And for our bigger, we have 5. So with that being said, again, smaller before the bigger, letter C and D are actually incorrect choices. So with our substituent, start ulit tayo with our spiro first. Okay, smaller ring again for spiro. C1 meron tayong bromo, C3 meron tayong chloro. And of course, our parent chain, ilang class ang ating total number of carbons including the spiro? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decane po siya with our alcohol at the C7 position. Our answer here is 1 bromo, 3 chloro, spiro 4, 5, decan 7, all. Ayan, so for number 15, answer is letter A. Next. 16. What is the name of the bicyclic compound shown below? Class, this is a fused bicyclic, sorry, not fused, bridged bicyclic compound because meron tayong bridgehead atoms. Okay, meron tayong bridge in our bicyclic compounds given here. This one, very straightforward, sir. Similar lang po kasi ang number of rings. Okay, number of carbon per rings, that's just equivalent to 2. Okay, 2 for here, excluding the bridgehead, 2 for here, and 2 for here. Also, nasa na nga po ulit ang bridgeheads? Ayan. So, class, remember, we always start counting at the bridgehead. So, with that being said, we should start here at the bridgehead that has a chlorine. So, at C1 position, meron tayong chlorine or chloro. Answer here, of course, hindi po si choice C and D. Sir, how about letter A? Class, mali si letter A. Okay, that is should be 222 octane. So our answer here is letter B because our total number of carbon, if you will count, including your bridgehead atoms, we have 8. That's 4 octane. So 16 answer is B. 1 chloro bicyclo, 222 octane. Alright, so that's it for our discussion on nomenclature. So class, now proceed na po tayo with stereochemistry. Okay, 5 items for stereochemistry or stereoisomerism. Let's have a quick recap on our isomerism. Class, again, for isomerism, we have 2 categories. Constitutional or structural, same molecular formula, different connectivity. For stereoisomerism, remember, we can also call it your optical isomerism. So under this class, you can also see geometric isomerism. Okay, aside from that, we have enantiomers, your non-superimposable mirror images of each other, and the stereomers, they are in the first place not mirror images because they only differ in one stereogenic center. Class, dapat very familiar na kayo with the formula 2 raised to n, where n is the chiral center because I think you've seen this in our evaluation exam. Okay, so with that, remember, for our requirements for chirality, we discussed this in our crash course, dapat po, sp3 hybridized si chiral center, meaning it has 4 different atoms or groups attached to it. Okay? So it also should have at least one chiral center and dapat walang plane of symmetry. Diba? We have that particular compound. Kapag mayroong internal symmetry, we call it your meso compounds. And they are categorized as a chiral molecule, an achiral molecule. Okay, so with that, start na tayo with our topics or items under isomerism. How many stereoisomers are possible for shikimic acid? So here is the structure and here are the choices. Class, here again, first thing to do is locate the chiral centers in your shikimate or shikimic acid. So here, sir, I think meron tayong 3 chiral centers. Very good. So with that, use only the formula. Class, straightforward lang to ha. Again, 2 raised to n since wala naman tayong internal symmetry. So, chiral centers, tatlo. So 2 raised to 3 equivalent to 8. So next. One hydrogen in one butene given by this following structure is replaced by bromine to give a chiral molecule. Which hydrogen is replaced? Class, take note, first thing to do here is to eliminate first those hydrogens that are attached to your carbons that are not sp3 hybridized. Also, meron ba? Yes, class, yung may mga double bonds, they are sp2 hybridized kasi. So, eliminate na agad natin si HA and HB because they are connected to your sp2 carbon. Diba remember, kapag chiral molecule, dapat sp3 ang carbon mo. So, it's just between C and B. Class, remember, they are both sp3 hybridized. Dapat meron siyang 4 different functional groups attached. Okay, letter D, kapag ni-replace mo to with Br, still, meron kang 2 H's. So, hindi pa rin siya chiral, sorry. But, for HC, ayan, if you replace it with Br, as you can see, it will be a chiral molecule. So, for number 18, class, easy question to. Remember, answer is letter C because here meron tayong sp3 carbon and meron tayong 4 different functional groups attached. When you replace a hydrogen with a bromine. Alright, number 18 is letter C. 19, so still under stereoisomerism, which substance is capable of existing in enantiomeric forms? You are given their corresponding IUPAC name. So class, translate niyo po muna with your structural formula in order to easily visualize the molecules here. Here are the line angle structural formula for the first 2 alkanes. Sir, yung isa, meron tayong plane of symmetry, and then, of course, we have no chiral centers available for our enantiomeric pairs. Okay, so next, with this one, of course, class, eto sana chiral center, but meron tayong 2 similar substituents. So for our alcohol compounds, 3-methyl-1-butanol, this is an achiral molecule, and ang answer natin here, class, is 2-methyl-1-butanol given by this structure. Sir, nasan po ang chiral center? Ito po, ang chiral center natin, we have methyl, ethyl, we have your methyl alcohol, and the last one, hydrogen. So for number 19, answer is letter D, 2-methyl-1-butanol. 20 actually, class, nag-appear daw to in the board exam last year. So this is derived from your 2017 USNCO National Exam Part 1. So E2-butene and Z2-butene, of course, they are alkenes, they are geometric isomers. They can react with bromine to form compounds with the following molecular formula. So, remembering the key feature of your bromination or in general, halogenation, what should be the relationship between the products? At last, di ba, anti-addition po kapag meron tayong bromination or halogenation. So here are the choices. This one pretty challenging daw to based on the kwento ng mga students. So here are the choices. So A, identical, B, enantiomers, C, diastereomers, or D, structural isomer. Okay? So, class, i-give ko na muna ang final answer. So, this is an NCO question. Answer is diastereomer. The products will be just different in one stereogenic center. Really, sir? Class, check natin yung different mechanism of bromination for E2-butene and Z2-butene. First, start tayo with our E2-butene. Ayan, for our E2-butene, recall, anti-addition po dapat ang bromine natin. So kapag meron kang E-isomer, class, again, they are at the opposite side. So as you can see, once you form your carbocation, yung methyl groups are at the opposite side. So if you, of course, attacked our particular carbocation here, your bridged halonium intermediate, anti-addition, so as you can see, si bromine, so they should be at the opposite sides as well. So usually, class, ang configuration is different. SR, RS, or RS, SR. So of course, again, they are always different in terms of the C2 and C3 configuration. Okay? So for our Z2-butene, class, remember here, of course, they are at the same side, but dapat opposite pa rin po si bromine. So with that being said, class, when you form our vicinal dihalide, they will adapt this particular configuration. Comparing this on our E2-butene products, o diba the first one, SR. So they are only different in one stereogenic center sa C3 po. So they are diastereomers. Remember na ha, this particular question coming from your ACS Olympiad. So si letter A, of course, they are not structural isomers because classing naman po yung connectivity nila. Each atom is connected or not connected to each other atom with the same numbers and kinds of bonds. Clearly, hindi sila enantiomers because they only differ in one stereogenic center. Alright, and clearly, hindi rin sila identical. Okay? Magkaiba po sila ng spatial arrangement. Class, sana clear yun ha? So don't worry, I will also emphasize this again in our final coaching. But for now, let's proceed with our last item under your stereoisomerism. Which of the following sugars possesses the configuration? Class, kapag may sugar kayo, usually ang R, similar lang siya sa D configuration. Your hydroxyls are at the right. Pag S or L, your hydroxyls are at the left. Okay? So remember, ang priority carbon natin is the one that participates in your carbonyl functional group. So this is C1, C2, C3, and then C4. So lahat ng choices merong R configuration because nasa right side po si hydroxyl group. Remember our particular discussion in biochemistry. Okay? So here lahat sila may R. How about sa 3 position? Class, here at our 3 position, only choices A and B ang nasa R configuration. This one kasi they are at the S configuration. Okay? And of course, between A and B at the C2 position S. So that's for our B sugar. So for number 21, our answer is letter B. 2S, D, R, 4R. We have left, right, right in terms of our hydroxyl groups. Ayan. So we are done with stereochemistry. So let's proceed now with organic reactions. Class, remember ha, yung crash course natin in organic reactions, we also covered pericyclic reaction. Okay, pag electrocyclic, ring opening or closing, one new sigma bond is formed for ring closing or broken for ring opening. Class, pag pericyclic, remember ang keyword, concerted reaction. Alright, next we have cycloaddition. Two new sigma bonds are formed or broken. Diba? Ang very, very famous type of cycloaddition is Diels-Alder reaction. Question pa nga yan sa item 22. And lastly, for sigmatropic, usually we have 3-3 sigmatropic rearrangement. We have named sigmatropic rearrangement, cope, pag gumamit ka ng 1,5-diene like this one, or your Claisen rearrangement kapag meron ka namang ether initial reactant. So for sigmatropics, one new sigma bond is formed as another breaks. Class, with that, start tayo with item 22. What is the product of the Diels-Alder reaction between this 2-methyl-1,3-butadiene and malic anhydride, your dienophile? Sir, hala, hindi kami familiar with the structure ni malic anhydride. Class, again, pag anhydride, this is the structure. This is, of course, a carboxylic acid derivative. So, from the nomenclature itself, you can already figure out the anhydride here. So, class, ang answer is letter B, following our arrow pushing. Okay, again, dapat familiar na kayo pag anhydride. We have carbonyl functional groups, and of course, derivative siya ng carboxylic acid, not our original or initial carboxylic acid molecule. So, for number 22, answer po is letter B. So for our next item, this is in relation to your sigmatropic rearrangement. So we have Cope and Claisen rearrangement. So we discussed this in the crash course for this particular discussion class. Ayan, Cope, 1,5-diene, Claisen, meron tayong allylic vinylic ether. And here class, again, meron tayong irreversible. Okay, pag allylic vinylic ether, meron tayong irreversible, of course, reaction, for our formation ng unsaturated ketone. Okay, very highly unstable po kasi ang formation ng cyclic transition state. So if favor niya ang formation ng final product in our allylic vinylic ether sigmatropic rearrangement. Class, again, this one, it should be irreversible. So it should only point out sa formation ng unsaturated ketone. So with that, let's proceed with our next item. If the molecule below undergoes a 3-3 sigmatropic rearrangement, which of the following will be the product? Class, again, for 3-3 sigmatropic rearrangement, always remember, that's just applicable for 1,5-diene. Sir, ito po ba is a Cope rearrangement? Yes. Okay, we will treat your phenyl and methyl here as substituents. Okay, so from the 1-1 position, so C1, C1, C2, C2, C3, C3 position, class, what should be the answer? Remember, migration lang po yan ng sigma bonds across the pi bond. Okay, so answer here is letter A. So class, remember ha, again, starting from your C1 bond, we just migrated the sigma bond across your pi system to form the 3-3 new sigma bond. So for number 23, answer is letter A. Of course, this is your Cope rearrangement. So number 24. Again, this is a board exam question, so somehow challenging daw to. Let's discuss. Which of this would be true if carbon atom in methane were in its excited state? Class, if you excite your carbon in its ground state towards its excited state, of course, the 2s electron, that one particular 2s electron will be excited to the 2p, of course, position. Class, remember yung valence electrons lang po yung pinag-uusapan natin here. The 1s, of course, is not a valence electron. Okay, that's why upon excitation, only the electron in the 2s position will be excited to the 2p orbital. Okay, so here, let's now discuss this particular concept. One electron each in 2s and 2p orbitals. So that's correct. Again, class, this is upon excitation. Number 2, C is tetravalent. So this is still true even upon excitation because again, strict follower po. C, carbon ng octet rule, hindi naman po magbabago yung number ng valence electron in our bonding region. We still have 4 electrons. Okay, number 3, 4 equivalent CH bonds. Class, do we have 4 equivalent CH bonds? Sir, no po. Actually, ito, different po ang bonding with our 2p orbitals. That's why, third choice or third statement is false, but the fourth statement is true. Somehow kasi they are opposite or they are different from each other. So either one of them is false, and that is the third statement. Class, meron tayong 2 types of CH bond. This 2s orbital electron and 2p orbital electron will allow different 2 types of CH bonding. Okay? So class, remember, for our hybridized state, ito po yung may 4 equivalent CH bonds. Okay? So for our item 24, answer is letter C. And particularly for our methane, we have sp3 and S coming from your hydrogen overlapping. Alright, so I hope it's clear. Again, number 24, answer is letter C, 1, 2, and 4 only. Last item under our organic reactions. Which of the following statements is not true for a carbocation ion? Concept based, so class ha. Letter A, a carbocation ion may combine with a negative ion. So that's your carbon ion. Okay, so this is true. Class, again now we will discuss the language keywords for concept based. Here we have may as our keyword for choice A. Letter B, a carbocation ion may rearrange to form a more stable carbocation ion. Remember, your alkyl shift and hydride shift. It may rearrange. So somehow, probabilistic yung approach ng statement. Letter C, sir, parang obvious, a carbocation ion does not. Parang ang strict niya. Okay? A carbocation ion does not remove a hydride ion from an alkane. How about the hydride shift? Okay, class, choice C is a false statement. Okay? In fact, carbocation ions can remove a hydride ion from an alkane through hydride shift. And letter D, a carbocation ion may alkylate an aromatic ring. Okay, that's your Friedel-Crafts alkylation. So for number 25, answer is letter C. Carbocation ions are electron deficient and they are highly reactive. They can combine with nucleophiles, rearrange for stability, or act as electrophiles in alkylation reactions. So 25, our false statement is letter C. Okay, so now we are down to our second to the last topic under basic organic chemistry. This is for alkanes and cycloalkanes. Class, start tayo with item number 26. The reactions below represent a possible mechanism for the chlorination of methane. Indicate which of the statements below is or are true. Actually, board exam question to during our time. Class, this one is derived from GRE model test. Let's discuss ha. Here is the following reaction mechanism for the free radical substitution or halogenation for our alkanes. So number 1 statement, steps 2, 3, and 4 represent the chain propagating step. Okay, so class actually is the fourth. Okay, the fourth step is actually a termination step. Okay, a possible termination step. So our first statement is a false statement. Next, if oxygen is added to the reaction vessel, the series of reactions shown above would proceed more rapidly. Oxygen would catalyze the reaction. Class, actually, the mechanism is the polar opposite. Our second statement is, again, false. Okay? So, oxygen actually will inhibit. It will not catalyze the reaction. Because in our halogenation, it will react with your free radicals. Okay? It will react with them to form your stable peroxy radicals. Thereby, it will slow down the propagation step. Okay? Remember, oxygen will not catalyze, but it will inhibit your free radical halogenation. And number 3, step 4 is most likely the rate determining step. Class, the rate determining step is step 2. Okay, it is the obstruction of hydrogen by chlorine and not step 4. So actually, it's either step 2 or step 3. Okay, and then our fourth statement is step 5 represents a possible termination step. So this is actually our obvious true statement. Okay, so remember, number 26, we only have one true statement. Step 4 is item 4. Step 5 represents a possible termination step. Class, please put an asterisk na. Again, this is a board exam question. 27. Alkanes are also known as, even without the choices, you can already guess the correct answer. They are paraffins. Okay? Paraffins for alkanes, olefins for alkenes, acetylenes for alkynes, arenes for aromatics. Alright, so class, again, concept based lang yan. Alkane is our saturated hydrocarbon compound. So for 27, answer is letter A. Next. In which dimethyl cyclohexane are both methyl groups equatorial in its most stable conformation? O, diba we discuss how we convert your particular line angle structure to your chair conformation. Class, again, here kapag staggered ang conformation, they have alternatingly up and down, equatorial and eggshell position respectively. So here are our particular positions. Okay? Are you sir? Class, for easy visualization, let's convert the choices into its chair conformation. Okay, class, again, for choice A, wala tayo actually here particular positioning because they are both attached to a single carbon. Okay, so here, of course, they are at the same carbon. One is axial, one is equatorial. Letter B, they are at the same side. So, one is axial, and then one is also equatorial. So, letter C, they are trans. So, both of them are equatorial. One is pointing down, one is pointing up. And letter D, of course, they are at the opposite side. So, they are trans. One is pointing down, one is pointing up, particularly equatorial and axial, respectively. So, for 28 class, our answer is letter C. O, dapat at this point, very knowledgeable na kayo in converting your line angle structural formula to their corresponding chair conformation. Okay, 29. Which of the following reactions is not usually stereospecific? A. Free radical substitution. B. SN1. CE2 or D. Hydrogenation with hydrogen with palladium catalyst. Class, again, not stereospecific. Ang reaction ni alkane with halogenation, that's your free radical substitution. O, diba, si SN1, meron pa nga tayong racemization. Stereochemical outcome is characteristic. So, still counted as stereospecific in that sense. Si E2, meron tayong inversion ng configuration. Okay, I'm sorry, not inversion. Meron tayong anti-periplanar elimination. For hydrogenation, of course, scene addition. Okay, class, again, clarify. SN1, racemization. CSN2, inversion. E2, anti-periplanar elimination. Okay, you discussed this in your alkyl halides reaction. Okay, on next item, number 30. During the complete combustion of methane, what change in hybridization does the carbon atom undergo? Actually, nag-appear daw to last year in the actual board exam. So, class, again, methane, ang carbon dyan is sp3, not sp2. So, you can already eliminate choices C and D. Ano po ba ang carbon-containing product in our combustion? Sir, if I recall correctly, parang carbon dioxide yun. Class, for carbon dioxide, we have two double bonds where your carbon participates in those double bonds. So, in that case, si carbon po ay hindi sp2. Okay? Remember, kapag meron kang two double bonds, it will now adopt sp hybridized orbital. So, in complete combustion, methane's carbon will start as sp3, but ang product ng combustion, again, is carbon dioxide, where carbon now is an sp hybridized atom. Remember po, linear ang geometry ni carbon dioxide. So, from that information, enough na po na makonclude nyo na sp hybridized orbital si carbon in carbon dioxide. Okay, 31. Of the following isomers, which of the following is the most thermodynamically stable? Class, remember, ang preferred thermodynamically stable position is equatorial. So, that's why, class, again, meron ba tayong equatorial? Yes, sir. That's choice B. Okay? For our choice A, meron tayong axial. Choice C, may axial. Choice D, axial. Straightforward question to class. Easy question. Remember, in disubstituted cyclohexane, the equatorial conformer is the most thermodynamically stable. Again, in order to prevent or minimize 1,3-diaxial steric interactions. Okay, for 31, don't forget, answer is letter B. Equatorial conformer. So, with that, we arrive now. Hindi pa tayo tapos, but this is the last item for our alkanes and cycloalkanes. A 1 gram sample of which compound will produce the greatest amount of carbon dioxide after complete combustion with excess oxygen? Class, stoichiometry lang to ha. Again, we will just get the carbon dioxide produced in moles. So remember, this is using the concept in general chemistry. Class, pakilagyan ng asterisk, nag-appear kasi ito last year in the board exam. Okay, sa yung 1 point. So, let's discuss the answer. For methane, so 1 gram ng methane, remember, molar mass 16 gram. For our stoichiometric ratio, 1 methane will produce 1 carbon dioxide. So, our carbon dioxide produced is around 0.0625 moles. So, next. For propane, so class, again, for 1 gram ng propane, molar mass 44 grams, stoichiometric ratio, 1 mole will yield 3 moles ng carbon dioxide. Our produced carbon dioxide is around 0.0680. And letter C, actually, this is the answer. So, 1 mole ng, class, this is just simply a phenyl. A benzene ring, of course, 1 gram will produce, of course, 0.0770 mole ng carbon dioxide. Remember, class, ang stoichiometric ratio, 1 mole ng benzene ring or phenyl will produce 6 mole carbon dioxide. O, sir, hindi po ba letter D ang correct answer? So, actually, class, letter D, masyadong dikit ang ating carbon dioxide produced with letter C, CH18. So, here, 1 gram ng ng C8H18. This is octane, 114 grams molar mass. Our stoichiometric ratio, 1 mole ng octane will yield 8 moles ng carbon dioxide. This is equivalent to around 0.07 moles ng carbon dioxide. So class, remember na yung final answer. For 32 again, here we will yield the greatest amount ng carbon dioxide upon complete combustion ng benzene. Alright, for number 32, answer is letter C. So now let's proceed with our last topic for our basic organic chemistry, alkenes, dienes, and alkynes. So let's start with item 33. Which of the following is true when halogen adds to an unsymmetrical alkene? So this is our halogenation reaction of alkenes. Let's check the key features. Class, again, yung choices. It's just all about the key features. A, syn addition occurs. B, the two X atoms are opposite each other. Remember our test taking tip. Choices A and B, they are polar opposites. Okay, yung isa syn addition. This one is just an approach to define anti-addition, diba? They will be opposite to each other. So class, remember ang key feature ng halogenation, it should be opposite to each other. Addition should be opposite, remember, due to the bulky nature of your halogens. For number 33, answer is letter B, but check din natin ang choices C and D. In the first step, homolytic cleavage occurs when your halogen breaks the double bond. Class, again, homolytic cleavage, ang product niyan is radical. Our reaction is ionic through formation ng halonium intermediate. Okay? Remember that. And choice D, hydrogen. Doon palang mali na, wala po tayong participation ni hydrogen. Okay? Here, we only use two different halogens. We don't use hydrogen. This is for hydrohalogenation. Wag ma-confuse ha. Again, tama si letter D, but hindi siya related to halogenation. So, halogen addition to an alkene or halogenation gives anti-addition product where the two halogens end up opposite each other. So, for 33, our answer is letter B. Next. 34. Class 34 dapat to ha. Sorry for the typo. Which of the following reactions proceeds via carbene or carbenoid intermediate? Class, for some question to. Okay? I repeatedly emphasize this in our crash courses. This is the particular, familiar, your cyclopropanation reaction. Particularly, Simmons-Smith. This is a name reaction. Class, hindi Sam Smith ha. Yung ibang students, akala nila Sam Smith again. This is Simmons-Smith cyclopropanation reaction. Alright, so for 34, answer is letter C. Next. 35, a compound that contains oxygen, C3H8O, undergoes dehydration with concentrated H3PO4 or phosphoric acid. The product labeled X rapidly decolonizes a solution of bromine in carbon tetrachloride. Class, from here pa lang alam nyo na this is a nucleophile because it can react with bromine. Okay? Determine the identity of product X. So here, class, first list po ang particular reaction. Dehydration and then bromination. And then nag-start ka daw with an oxygen-containing compound. From your discussion sa alcohols, class, your alcohols can be dehydrated to form what is the product under elimination? Alkene. Okay? Sir, again, after alkene, if we brominate it in our reactions, electrophilic addition with alkene, we will form your vicinal dihalide, particularly alkyl bromide. So class, starting from C3H8O, of course, retain ang number of carbons, product will be propene. Alright, for number 35, again class, dapat marunong na kayo mag-interpret ng reactions when it is in a paragraph form. For 35, answer is letter C. Propene po ang answer. Okay, on number 36. Dichlorocarbene adds readily to propene to form a class, again, carbene na naman. So this is cyclopropanation or Simmons-Smith reaction. So here, class, again, very straightforward. Okay, easy question to. So ang answer here, the product will be a dihalocyclopropane, particularly dichlorocyclopropane, choice D. Alright, so class, quick recap lang ha on our Simmons-Smith reaction. So remember here, we have two steps. First one, formation ng organozinc reagent. This one is highly polarized, so readily available for attack C, CH2 or the carbene. Okay, it can react with your alkene in our step 2 to form the cyclopropane ring. So class, again, similar lang yan if you have a dihalocarbene. So this one, very obvious lang po na we have a carbene in our particular nucleophilic attack. So this is a simultaneous reaction, concerted mechanism in order to form two new carbon-carbon single bonds. So class, again na, emphasis on the concerted reaction mechanism. So here po, our product again is cyclopropane. Alright, so let's proceed with our third to the last item. Which of the following compounds can contain exactly one triple bond? O sir, parang repeat yan from our previous items of structure and properties. So yes, this kasi class nag-appear siya sa board exam during our time. So answer again, you will use here the DU formula, or if you know the general formula, answer is letter C, C6H10. 38, nag-appear 2023 and 2024 board exam. So, lagyan na po natin ng asterisk. Which of the following describes the position of the hydrogen in the given structure? A geminal, B vinylic, C allylic, or D vicinal. This is our structure. Class, again, here, when we say vinylic carbons, class, those are carbons that participate in our double bond formation. And correspondingly, yung hydrogens attached to them are also vinylic. Actually, that's our answer. So, pag meron kang carbon that participates in your alkene, that's your vinylic carbon, and the hydrogens attached are your vinylic hydrogens. Okay? For those carbons adjacent to a vinylic carbon, that's your allylic carbons. And correspondingly, hydrogens attached to it are allylic hydrogens. Okay? Class, when we say geminal, or for instance, let's take into consideration this particular carbon, hydrogens here are geminal because they are attached at the same carbon. If you have a vicinal hydrogen, they are at the adjacent carbons. They are attached to adjacent carbons. Alright, so wag mako-confuse between vinylic and allylic and geminal and vicinal. So now, let's proceed with our last two items under polymers. Okay, class, again, na-discuss na po natin to in our crash courses. So class, again, chain growth polymers is just synonymous with your addition polymers. So they are formed usually from the reaction ni alkene. So yung discuss natin sa crash course, that's just free radical polymerization. But aside from that, we can also do cationic or anionic polymerization. So similar, of course, with these three different intermediates, we have an initiator. So again, class, always po, Even though you use different types of intermediate, need mo po ng initiator. Di ba remember, we use peroxides. So again, here for radical, we have your peroxides, cationic, so necessary na Lewis acid. Of course, for instance, meron kang boron, trifluoride. And for anionic, so actually, it's organolithium. Okay? So class, no need to memorize this. Supplementary na lang po to. So usually naman, free radical polymerization ang involved in our actual board exam. Okay? So usually here, class, we will yield different types of polymers. So I think you are already familiar with this type. So we have HDPE and LDPE. Again, different lang po yun with the branching found in our polymers. High density polyethylene, of course, very minimal ang branching. Low density polyethylene, ayan, highly branched siya, class. So for PET, we have polyethylene terephthalate. So this is actually a resin. And polypropylene naman po, of course, our monomeric unit is coming from propene or common name propylene. Alright, so usually, class, makikita mo yan sa bottles. This symbol, of course, these symbols are for identification ng type ng polymer that was used in manufacturing this liquid bottles. Okay, class, again quick recall lang tayo ng HDPE versus LDPE. So don't worry, this one very easy. For high density, again, linear. For low density, branch. So, our monomeric unit here is ethylene, a 2-carbon containing compound. So, linear polyethylene, highly dense yan because they can pack well. For your branch, so ayan, medyo messy po ang structure niya. So, it cannot pack well. That's why it has a very, very low density. So, pag synthesize po ang high density polyethylene, class, familiar ba with your Ziegler-Natta polymerization? Okay, so remember, class, nag-appear na to 2022 if I'm not mistaken. Ziegler-Natta polymerization. Again, this is particular for ethylene formation ng high-density polymer. So high-density meaning it is linear. Ang chain niya ay linear. It can closely pack together to form a rigid polymer. So ano po yung exact question sa board exam? Class, ano raw yung nature ng Ziegler-Natta catalyst? So this is discovered by Carl Ziegler and Julio Natta. Okay, so class, again, in terms of the nature ng catalyst natin, this is titanium tetrachloride. Okay, this is a chemical compound, particularly a transition metal titanium, and an organometallic compound like triethyl aluminum. So class, again, this is our catalyst, Ziegler-Natta catalyst organometallic compound. So meron tayong titanium center. So this is used in the synthesis of HDPE. So again, just remember, Ziegler-Natta, this is a titanium-based catalyst. Alright, because for steps 2 and 3, ayan, this is our growth na lang yan. Chain growth. Okay, chain elongation via formation ng carbon-carbon single bond. Class, again, meron kasi tayong very polar bond in our catalyst, so it will induce the chain elongation process here to form our carbon-carbon new single bond. Okay, so with that, let's now proceed with our last 2 questions. What is the product of the given reaction? So class, again, this is just ethylene. O sir, again, this one, kapag hindi ka gumamit ng Ziegler-Natta, usually branched polyethylene ang product. Kapag naka-specify, class, or specific na nakalagay here is titanium tetrachloride with your alkyl aluminum organometallics. So of course, your product will be linear polyethylene. Okay? Polymerization of ethylene produces a long chain product, polyethylene. So 40, all of the following are condensation polymers, except, so class, nag-appear to during our year 2023. Answer again is si polyethylene, class addition polymer yan. Okay? So as a summary, so here are the following types and monomers of our given choices. Si nylon, condensation yan ng polyamide, particularly your hexamethylene diamine, and adipic acid is, of course, our particular monomers. For polyethylene, again, addition via the use of our ethene monomers. Class, again, this one is used to create plastics or bottles. So I think familiar naman na kayo with the nylon. Okay? Usually ginagamit yan as a lubid if you're familiar with that. Letter C, PET or polyethylene terephthalate. So condensation polymer din siya, your polyesters. Usually ginagamit sa manufacturing ng clothing lines. Okay? Our monomers here, terephthalic acid plus ethylene glycol. So diol lang to, class. Okay? Glycol, its IUPAC name is diol. And bakelite, again, is a resin derived from the condensation of phenol and form aldehyde. So for number 40, answer is letter B because addition polymer siya, class. Ayan, so we are done with our part 1 discussion ng answers to your evaluation exam. Class, you can pause the video, double check your answers. Hopefully, you got a passing score. It must be equal or higher than 70%. So, next thing to do, please continue watching our part 2 discussion of your eval exam for items 41 to 80. So, with that, class, I will now say goodbye and I will see you on final coaching. Class, take our multiple choice question sets seriously. They are all board exam relevant questions. So, class, yun na muna. Bye for now.